Hello students, today we will discuss and will continue the chapter normalization. So we'll see normal forms in a database management system. So please have a look. First normal form. The first normal form says that all the domains of a relation must be atomic. Now the first question arises here, what is domain? So domain is a set of permissible value stored at particular moment of time in a relation. So whatever value is stored in a database, that must be atomic by nature according to first normal form. Atomic means that cannot be further broken down into subparts. Now, the process means attributes in a relation will not contain any values that can be further broken down into different parts. Like whenever we need to store information about a student, we always store the name of the student. So making one single column for name will not follow the rule of first normal form, because this name information can be further broken down into three different parts like first name, middle name and the last name. That is why this name column or the name attribute is not atomic by nature. So as per the first normal form, we have to take care of the atomicity of the domains. So if my database is in first normal form, it must follow the atomicity, means every domain must be atomic by nature. So first normal form disallows composite attributes. Composite means one attribute is made of different attributes values, so that is not allowed in first normal form. And multi-valued attribute, it also disallows multi-valued attribute, means that must be a single valued attribute. And the nested relations, attributes whose values for an individual tuple are non-atomic, means these nested relations are not supported in the first normal form. So as a summary, we can say in first normal form, every domain must be atomic by nature. There should not be any composite attribute, there should not be any multi-valued attribute, and there should not be any nested relations available in the database. If my database follows all these rules, that means my database or my relation is in first normal form. Now move to second normal form. Second normal form. The second normal form uses the concept of functional dependency that was not available in the first normal form. So here the functional dependency, we have already discussed the concept of functional dependency. We have already discussed the concept of primary key. So this second normal form is based on the concept of functional dependency and primary key. So as per the definition, so prime attribute means an attribute that is member of the primary key, we have already discussed. Now full functional dependency means a functional dependency like Y tends to Z, where removal of any attribute from Y means the functional dependency does not hold anymore. Means Z is fully functionally dependent on Y. So as per the second normal form has functional dependencies where all the non-prime attributes are fully functionally dependent on the prime attribute according to second normal form. Here in the example we can see there is one composite attribute, that is SSN number and P number. Both these values are making a key which can identify hours, is a full functional dependency, since neither this SSN tends to hour nor P number tends to hour, means SSN cannot individually identify hours and P number can also can not find hours. So if we combine this SSN and P number, then only we can find hours. So there is no partial dependency, means there is a fully functionally dependency. Hour is fully functionally dependent on SSN and P numbers. So this is the example of second normal form. Here in the next example, SSN number and P number in combined form can find E name is not a full functional dependency. It is called a partial functional dependency. Since SSN number can find E name, means if you have SSN number, you can easily find employee name. So that is not following the concept of fully functional dependency. So this SSN number and P number, when finding E name, is not called a fully functional dependency in the relation. So second normal form always follow fully functional dependency concept. So it always allow fully functionally dependency. That means all the non-prime attributes are fully functionally dependent on the prime attribute. If this situation or if this case is available, it is called second normal form. Now move to the next normal form. And one important information about the relation, by definition we can say a relation schema R is in second normal form if every non-prime attribute A in R is fully functionally dependent on the primary key. Now comes to the third normal form. By definition, there is a transitive functional dependency we have already discussed. So a functional dependency X tends to Z that can be derived from two other functional dependencies, that is X tends to Y and Y tends to Z. So according to transitive functional dependency, we can say X tends to Z. So third normal form, we have transitive functional dependency. So here, like SSN number can find DMG or SSN number, it is a transitive functional dependency. Why? Because SSN number can find D number and D number can find DMG or SSN number. So we can say SSN can easily find DMG or SSN numbers. Here in the next example, SSN can easily find employee name is a non-transitive. Why? Because there is no set of attribute X where SSN tends to X and X tends to E name. So there is no such functional dependency available. So SSN tends to E name is a non-transitive functional dependency. So third normal form always allow transitive functional dependency. So a relation schema R is in third normal form if it is in second normal form. Every higher normal form obviously follow the lower normal form and add some new features or new constraint so that the relation can be normalized in a better way. So a relation R which is in third normal form, if it is in the second normal, the first condition is to be in the second normal form, and no non-prime attribute A in R is transitively dependent on the primary key. That means no non-prime attribute transitively dependent on the prime key. There should not be any transitive functional dependency on the non-prime attribute. Means no other non-prime attribute dependent on the primary key. So R can be decomposed into 3NF relations via the process of 3NF normalization. So here in the example, if in X tends to Y and Y tends to Z with X as a primary key, we consider this a problem only if Y is not a candidate key. X tends to Y and Y tends to Z. So this is means there would be a problem if Y is not a candidate key. Means Y must be a candidate key, must be a prime attribute. And when Y is a candidate key, there is no problem with the transitive dependency. For example, consider a EMP relation where SSN number, EMP has, and salary are the three different attributes in the relation. So SSN tends to employee ID tends to salary, and employee ID is a candidate key. So there is no problem. But if a non-prime attribute, if suppose employee ID is a non-prime attribute, then there will be a problem, because in the third normal form, no non-prime attribute is transitively dependent on the prime key. That is not allowed in the third normal form. So in the third normal form, prime attributes are transitively dependent on the prime attribute, or we can say primary key. This is the third normal form. Thank you. In the next video, we will continue the process of normalization. Till then, bye bye.